Okay, so we are now on page 12 of our Unit 8 course pack, and we are now going to add one additional element to our stoichiometry problems, and that is the gram to mole conversions. So a lot of times in lab, you've noticed that we haven't specifically been working with moles of things, but instead we've been working with grams, or we use the balance to measure 3 grams of something, and then that's what is reacting. So in the lab, that is what happens, and there's a way that we can use the amount of grams and our mole-to-mole ratios to figure out how much of our product is going to be formed or how much of our reactant is necessary to complete the reaction. So it's going to look very similar to our previous problems, except for there will be an additional step where we have to convert grams to moles. So let's look at number 1. Solid aluminum metal reacts with chlorine gas to produce solid aluminum chloride. So let's go ahead and write out our equation. So we have solid aluminum reacting with chlorine gas. And because chlorine gas is a diatomic molecule, we need to have the subscript 2. So that's going to produce solid aluminum chloride. And the charge of my aluminum is 3+, and the charge of my chlorine is 3-. So that means I'm going to need 3 chlorine to create a neutral compound. So I'm going to add a 3 subscript to the chlorine. And then in order to balance this equation, take a minute to think about what coefficients need to be added in order to keep this balanced. Okay, so we need a 2 here, and we need a 3 here. And the aluminum will also need a 2. And now our reaction is balanced. Okay, so next we have our before, change, and then after our reaction. But you'll notice that instead of giving us moles of something, they give us grams of solid aluminum. So what we need to first do is calculate the amount of moles that are in 61.5 grams of solid aluminum. And we are going to use, on the periodic table, if you remember, there is the molar mass of the elements, and that's what we're going to use to convert grams to moles. So we have 61.5 grams of aluminum, and that is the molar mass of aluminum is 26.982 grams per mole. So in order to get moles on the top, I'm going to flip it and put the 26.982 grams on the bottom per 1 mole. And that will give me the number of moles of aluminum. So go ahead and do that calculation on your own. Okay, and you should have gotten 2.29 moles. And so now, before my reaction starts, now I can fill in that information. So I have 2.29 moles of aluminum, and I have an excess amount of chlorine, so I can just put excess or XS to represent excess chlorine. And then my aluminum chloride is 0 at the beginning because none of it has reacted yet. Okay, and it says 100% yield. That means that all of the aluminum has reacted. So I can do minus 2.29 moles of aluminum here, and that will give me a final amount of aluminum of 0 moles. Okay, and if I have 2.29 moles of aluminum reacting, I can solve for my chlorine gas because it's a 2 to 3 ratio, So I'm trying to solve for this number. So I use my proportions. And I multiply 3 by 2.29 to get 6.87. And then I divide that by 2. And I get 3.3. So that tells me that 3.3 moles of chlorine reacted to produce this amount of aluminum chloride. So this is a 2-to-2 ratio, which is helpful because that means that however much aluminum solid reacted, that same amount of aluminum chloride was produced. And that will give me a final molarity of 2.29 moles. And this is still going to be an excess because there's a large amount of it. Okay, so my final answer is they're asking how many grams of aluminum chloride crystals will be produced. Okay, so we're not finished. We have moles right here, but what is the question asking for? It's asking for grams. So we need to take our 2.29 moles of aluminum chloride and convert it to grams of aluminum chloride. So for every 1 mole of aluminum chloride, I need to figure out how many grams of aluminum chloride I have. And I do that by adding up the molar masses of my compound. So the molar mass of aluminum is 26.982. And then I add that to my molar mass of chlorine. But since there's 3 of them, I need to multiply this molar mass by 3. To get a final molar mass of 133.33 grams per mole. So I can plug that number in right here and multiply it by 2.29. And I'll get a total amount of 305.33 grams of aluminum chloride. Okay, but I need to check my sig figs. So my initial amount that is given in the problem has 3 sig figs. So that means that my answer should also have 3 sig figs. So my final answer should be 305 grams of aluminum chloride.